When we looked at the full circular flow diagram, two equations emerged. Real GDP is equal to consumption plus investment plus government purchases plus net exports. And domestic savings is equal to investment plus net exports. The first equation emerged on the left-hand side of the circular flow diagram, where if output markets are in balance, what's being produced must be equal to what's being purchased, and the people who are purchasing are the government, households, firms, and the rest of the world. The second equation emerged on the right-hand side of our diagram, where if financial markets are in balance, what flows into those markets must be equal to what flows out. What flows in is household savings and government savings, which together make up domestic savings. What flows out is investment and net exports. We also observed that whatever is being produced in the economy flows back as income to households, and households can only do one of three things with their income. They can either consume, pay taxes net of transfers, or save in financial markets. That allowed us to come up with a third equation. That equation says that income has to be equal to consumption plus taxes net of transfers plus household savings. And that third equation has to hold by definition. Whatever income households receive, they can either consume, pay taxes net of transfers, or save. But the first two equations are what we call equilibrium equations. They emerged because we assumed that output markets and financial markets are in balance, are in equilibrium. So we're going to put that third equation in parentheses to indicate it holds by definition. But for the first two are equilibrium equations. We also saw that we could use this definitional equation to get from the first equation to the second. Simply set the first and the third equal to each other, and the second equation emerges. What that tells us is that when output markets are in balance or in equilibrium, then financial markets are as well. So the circular flow diagram is a representation of what we call the macroequilibrium. But it doesn't answer the question of how we actually get to that equilibrium. To do that, we're going to simplify the economy at first. So suppose you're back in Puddletown. There's a market square where people are trading, and there's a bank. But there's no government, and Puddletown is entirely disconnected from the rest of the world. We call that a closed private economy. It's closed from the rest of the world, and it's private because there's no government. Now when we strip the government and the rest of the world from the circular flow diagram, we get this circular flow diagram. And now we can see whether we can find those same equations in this diagram. So first we can look at output markets. If output markets are in equilibrium, what's being produced must be equal to what's being purchased. But now only households and firms are purchasing, so it must be equal to consumption plus investment. If financial markets are in balance, then what flows in must be equal to what flows out. What flows in is household savings, which in this case is equal to domestic savings because there is no government. And what flows out is investment. So balance in financial markets means that savings is equal to investment. So we are getting simplified versions of these equations that simply drop whatever is due to the rest of the world or the government. G drops and NX drops in the equations. We can also write that third equation. When income flows back to households, households can now only do two things. They can either consume or they can save. So that means that income is equal to consumption plus savings by definition. And we can again see that we can get from the first equilibrium equation to the second equilibrium equation by simply using this definition. Set the first and the third equation equal to each other, and we get C plus I is equal to C plus S. But that can only hold if I is equal to S, if savings is equal to investment. So now we still have the question of how do we actually get to that equilibrium? And suppose that Sybil comes to you and she says, look, I've observed the Puddletown economy over the years in good times and in bad times, as income varied. And as income varied, I've observed how consumption changes and what investment is doing. Now, we've made investment here the same regardless of what income in the economy is. That's what we call in macroeconomics an assumption of exogenous investment. Whenever a variable in macroeconomics is determined outside of the system, it is called exogenous. When it's determined within the system, it's called endogenous. And of course, in the real world, investment depends on income. But to make things really simple, we'll first assume that investment is exogenous. So now Sybil asks you, I've observed all of this. What here is an equilibrium? And you could simply go to your equilibrium equation, the first one, which says that GDP is equal to consumption plus investment. So where in this table do we find that equation holds? Well, it doesn't hold up here. It holds where output is 10. Where output is 10, consumption is 8.4, investment is 1.6, and that sums to 10. So you could go to this table and say, well, the equilibrium lies here, because everywhere else, consumption plus investment is not equal to real GDP or real income. Okay, so we found the equilibrium in the table, but now Sybil comes back to you and says, well, how does the economy actually reach this equilibrium? And to answer that question, we have to do a little bit more work. The first thing we're going to do is we're going to put another column to this table that we're going to call sales. Sales are just what happens in output markets. And we can ask how much is being transacted in output markets in each of these rows. So in the first row, consumers are buying 0.4, let's say it's billions of dollars, $0.4 billion worth of goods and services. And businesses are buying $1.6 billion worth of goods and services. So in the marketplace in Puddletown, the total sales are $2 billion. In the second row, consumers are purchasing $2 billion worth of goods and services, and businesses 1.6 billion. So that gives us 3.6 billion. And similarly, we can fill out the rest of the table. 5.2, 6.8, 8.4, 10.0, 11.6, and 13.2. So now we know how much is being sold in the marketplace in each of the rows. Now we can ask, how could it be that there are sales in the marketplace, but no income in this first row? Where is this coming from? There's no production in the economy, there's no income in the economy, and yet there are sales going on in the marketplace. So where are the goods coming from? They couldn't be coming from the rest of the world because there is no rest of the world. They're not coming from the government because there is no government. They can only come from one place. They can come from the warehouses that firms have. They can come from what we call inventories. So the next column is going to be the change in inventories that we observe in each one of these rows. So in the first row, we have 2 billion worth of sales and no production. So all of those sales must have come from warehouses. So there's a change in inventories of minus 2.0 as inventories are being drawn down in those warehouses. What about the second row? Well, we have 3.6 billion in sales, but only 2 billion in production. So inventories are falling by 1.6 billion. And we can fill out the rest of the table. We get minus 1.2, minus 0.8, minus 0.4, 0, 0.4, and 0.8. So in the last row of the table, 13.2 billion of sales are happening in the marketplace and 14 billion are being produced. So that must mean that inventories are actually building in because all the production isn't being sold. Now imagine being a business. You're seeing your inventories decline. So you're somewhere in these rows and you're seeing your inventories falling. Your warehouse is being depleted. What are you going to do? Well, you're going to decide you should produce more because you don't want your warehouse to become empty. So when we see declining inventories, businesses have an incentive to start producing more. If we see inventories rising, then businesses are observing that their warehouses are getting fuller and fuller. They aren't able to sell everything they're producing, so they're going to start producing less. So whenever we have declining inventories, businesses are going to increase production and we're going to move down the table. But whenever we have rising inventories, businesses are going to cut back on production and we're going to move up on that table. So that's naturally going to lead us to this equilibrium, where in equilibrium there is no change in inventories. Whatever inventories you have, they remain constant because you're constantly selling what you're producing. That's when we're in equilibrium. So when Sybil asks us how do we get to the equilibrium, we get to the equilibrium by firms observing whether their warehouses are filling up or being depleted and adjusting their production accordingly. So we can now ask, do all of the conditions in equilibrium hold? We know where our equilibrium is, and we already know that at that equilibrium consumption is equal to income is equal to consumption plus investment, because that's how we found the equilibrium to begin with. But is it also true that savings is equal to investment? So we need a final column for savings. So savings, by definition, is equal to income minus consumption. So all we have to do is find our income and consumption columns, the first two columns. In the first column, people are consuming 0.4 billion, but they're not making anything. Where is this coming from? Well, it must be coming from their savings. So the savings in the first row are minus 0.4. They're drawing down their savings. In the second row, they're consuming 2 billion and making 2 billion. So their savings are unchanged. And we can fill in the rest of the column. 0.4, 0.8, 1.2, 1.6, 2.0, and 2.4. So in the last row, consumers are consuming 11.6 billion, but they're earning 14 billion in income. So they're saving the difference, 2.4 billion. Now we can ask, is this second equilibrium condition holding? Is saving equal to investment? And indeed, in this row, saving is equal to 1.6 billion and investment is equal to 1.6 billion. We've reached full equilibrium. The fact that we had an equilibrium in the output market meant that we also had an equilibrium in the financial market. So now we have an idea of how a macroeconomy actually gets to an equilibrium. Businesses observe changing inventories and they adjust production accordingly.